In this lesson, we'll learn about normal distribution. A normal distribution is a special type of frequency distribution. The general shape of a normal distribution looks something like this. Over here, the y-axis is the frequency and the x-axis represents the value. This is called a normal distribution because everything in nature, when in a large enough quantity, tends to show this curve over here. One example would be the IQ points. The entire IQ point system is built on a normal distribution where 100 is the midpoint. So if I have a distribution like this is the general shape. This tallest point over here, this is the mean. So for IQ system, 100 is the mean. There are some people with less. Half of the people have less than 100 IQ, half of the people have more than 100 IQ. Anything in nature, this can be IQ points, this can be the grades of an exam or marks achieved in an exam. We cannot do grades because that is a discrete variable. We can do marks. If I can grade the paper in decimal places, that is, we'll have an average mark over here. Half of the people will get more, half of the people will get less than that, and most of the people will get almost close to the average over here, and there will be exceptionals on both ends of the spectrum. So there will be students who get almost full marks over here, but they're rare, and so are the people who get almost zero. So both extremes are rare. Both extremes have a lower height. The general shape, so this shape over here, this is called a bell curve. The name bell curve comes from the fact that this general shape of a normal distribution looks somewhat like a bell. Now, a while ago in this video, I talked about how it cannot be discrete when we are dealing with a normal distribution. So we'll dive into the features of a normal distribution. So firstly, if we notice, the shape is symmetric, and it's symmetric about the highest point. The highest point is where the mean is. So there is the same shape on the left and right of this point. So the graph is symmetric, and it's symmetric about the mean. And as it is symmetric, it does not have any skew. We know that if there is no skew, the mean, median and mode will be equal. So that is the second property of a normal distribution, where the mean, the median and the mode are the same value. So all three forms of finding an average have the same value in a normal distribution. Now the third property is that it's for a continuous variable. So the variable is continuous. We cannot have a normal distribution for a discrete variable such as grades. Even marks achieved are generally discrete variables. We don't get marks like 39.321. It can only be 3940, or if you have some kind of partial marking, you can have 39.5. You won't have 39.43 as your marks. So a better example would be height or weight of everyone. That will be a normal distribution. If I take the height or weight of the entire Earth's population, it will be a normal distribution. Height and weight are continuous variables. Your exact height can be 193.42132 centimeter as well. This is your exact height. We can go finer and finer. So this is a continuous variable. We don't have any break. So in this case the variable is continuous. The fourth point, if you have noticed, on the extreme ends the graph goes on and on asymptotically. The graph moves asymptotically in both ends, so the range is from minus infinity to plus infinity. So range of the variable there is no end in the x-axis for this distribution. It goes on and on. It never touches the x-axis. And finally, this is a special point. We have to remember this. The area that is under the graph, so this whole area, this represents the probability. The area under the normal distribution is the probability. Now we know that for any case, the total probability is always 1. We know that. So total probability is always 1. So the area under the graph, the total area under the graph will also be equal to 1. We have to remember that the area under the curve represents the probability. So the area under the graph is representing the probability, and we know that the total probability is always 1. So the total area under the graph will be 1. This is the property of a normal distribution, that its area represents the probability. We also know that this is symmetric. So if I have the mean over here, this area over here to the right of it will be 0.5 and to the left will be 0.5 as well. The probability of anything being less than the mean. So if this is a variable x less than mean is 0.5, x greater than mean is also 0.5. Now if I want to write down that a variable is a normal distribution, we write something like this. So we write x, which is the name of the variable or the letter I'll use to represent the variable, and then I'll use this sign, and then I'll write n to denote that this is a normal distribution. Now we'll give a bracket and enter two values. Now these values will be the mean and the variance. So the properties of a normal distribution depends only on its mean and its standard deviation or the variance. This is how we write down that something is in a normal distribution. So if I have, for instance, in the case of IQ points, if I consider this variable to be I, I'll write down I is a normal distribution, its mean is 100, and its standard deviation is 15, so its variance is 15 square. This is the normal distribution of IQ points. Now we can have a lot of different types of normal distributions, and to find its areas, we'll have to find the area of this curve. Finding the area of this curve will require us to do calculus. We have to integrate this function over here. This gets tough. However, we know that it follows this general shape. So we can use some tricks to convert every type of normal distribution into a standard one. For this case, we use a standard normal curve. We denote the standard normal curve with the letter Z. Z is a normal distribution where the mean is 0 and the standard deviation or variance is 1. It looks like this. And this is the y-axis over here. This is x, this is f of x. Sorry, this is z. This is f of z. So by comparing any kind of normal distribution, so if I have the IQ point distribution over here, I'll first convert this into the standard one, and then I'll use the standard one to calculate our values. The advantage is that if I have a standard curve, I can convert everything into this, and I can just use a database or a data booklet for this. So I can have the frequencies or the probabilities of the standard curves area. So if I want to find this area only, I can just use a data book value. I can just take the probabilities of each value, or probability each 0.1 or 0.005 values here. So I can take the value of probability less than 0 is 0.5, and then I'll keep on writing. For example, I can have z less than 0.05. I'll have a probability of 5.5, 0.5 something. So if I take you to the data booklet that will be given in the A-level exams for Edexcel, the standard the normal distribution table is the same everywhere, regardless of what board you sit for. This is the normal distribution table that will be given. This function over here is basically the function of the normal distribution. This is the equation of this curve over here. For example, over here we are given the value when z is 0.01, the probability is 0.5040. So we can just have a table ready of every value, and then I can just compare this to find the probability. So from here, the probability z less than this value over here, so I can consider this value anything. So probability z less than blank, so any value I want I can just put in there, will be this value over here. This value is the probability of z being less than the value on its left. So the probability of z being less than 0 is 0.5. The probability of z being less than 0.01 is 0.5040. If I go on, I have values until the z value of 4, where it approaches almost 1. This is not exactly 1. Somewhere down the line, it's something like 0.99999. So it keeps on repeating nines, and somewhere down here we have a 1. So if I round this to 4 decimal place or 5 significant figures, I'll just get 1. But this is not exactly 1, this is slightly less. So this is how we use the normal distribution table. Getting back over here, the good thing about using the mean to be 0 is that corresponding values will just change sign. By corresponding values I mean, since this is symmetric, if I look at this value over here, suppose this is 1, then this value over here will be -1. So at the same height, this will be slightly over here. Yeah, this will be -1. The area on its right and the area on this side, they will both be equal. So this is one of the mathematical properties of a normal distribution. This is the property of the standard normal distribution. So the property is that z greater than alpha is a variable over here, is equal to z less than alpha, z less than minus alpha, and the opposite is also true. So this red area is the probability of z less than 1. This is also equal to the probability of z greater than -1. So the same thing, if I write it flipped, I can also write that probability z greater than alpha is equal to probability z less than minus alpha. Now another observation, for this I need one value only. This blue area, which is probability of z greater than 1, and this red area, which is the probability of z less than 1, if I add them up, this will be 1. So if I know either of them, I can find the other one. So the other property would be that the probability of z being greater than alpha, or z being greater than 1 over here. So this blue example is this case. This will be equal to 1 minus the probability of z less than alpha. If I look in this case over here, if I add them both up, I get 1. So probability z less than 1 plus probability z greater than 1 is 1. I can make either one of them the subject. If I make the blue one the subject, I get probability z greater than 1 equal to 1 minus probability z less than 1. So this is another formula for the standard normal distribution. We can use both of these equations or both of these formula to find another one. So if I have to find probability of z less than minus some 3 or minus 1.0, we don't have negative values on the normal distribution curve that we have seen. It starts from 0. So if I have a negative value such as -1, I cannot find this directly from the table. But we know that probability of z less than minus alpha, so probability of z less than -1 will be probability of z greater than 1. We cannot still use the table because the normal distribution is for less than. The table we are given is for z less than something. So we have to convert that. We already know the second form. Now we have to use this form or this expression to change z greater than 1 into 1 minus probability of z less than 1. Now we have z less than something. This is the format in which the table is given. So if I write it for general values, we'll get the formula z less than minus alpha is probability of z 1 minus the probability of z less than plus alpha. So this is the example. Hence, for a question like the finding, if I am asked to find the probability of z less than minus 1.27, I know that this will be equal to 1 minus probability of z less than 1.27. If you use the normal distribution table, you'll find that this is 1 minus 0.8980. This is 0.1020. Now we know that the normal distribution table values are given for z less than something. If I want to visualize that, if I am given 2 over here and I know probability of z less than 2, if I have to graphically represent it, this area over here is that. So probability of z less than 2 is this area. This allows us to answer some trick questions about normal distribution. So if I am asked the probability of a specific value, so if I want the probability of z being equal to 0, so the probability that z is on this line, this will be equal to 0. Since the area of a line if I'm asking the probability of z to be 0, it's basically saying that it's on this line. We know that the area of a line is 0. So for any value, probability of the variable being equal to any value is 0, since the equal to sign means that it's on the line. If it's on the line, it cannot have an area. It doesn't have an area. Its area is 0, so its probability is also 0. For this case, so for this reason, the probability of x less than equal to alpha is also equal to the probability of x less than alpha. Now we need to be able to visualize this case. In some cases, I'll have to find the probability of z being between two values. So for example, z is between 0 and 1.27. So the value must lie between 1.27, which is somewhere over here, and 0. So the area we want is this area over here. We know that the data book has this whole area given. This is the data book value for 1.27, which is 0.8980, and we have to subtract this red area over here. The red area is the probability of x being less than 0, since the only area we want is this part over here. So I have to subtract the red area, I have to subtract the red area from the blue area. The blue area is everything to the left of 1.27, the red area is everything to the left of 0. So we have to subtract the probability of 0 from this. So from here we have probability of z less than 1.27 minus probability of x less than 0. We get 0.8980 minus 0.5000. So the white area over here is 0.3980. So for any case where the probability of two values are to be found, so probability of z being between alpha and beta, will have probability of z being less than beta minus the probability of z being less than alpha. In this case, yeah, this is fine. We have to remember this fact over here as well. Now we have learned about the standard normal distribution and other forms of normal distribution. We also have to learn how to convert other forms. So for example, for IQ, I had a normal distribution with a mean of 100 and a variance of 15 square. We have to convert this into the standard normal distribution, which is the normal distribution with mean 0 and standard deviation and variance 1. The formula would be the z value is equal to the value of I minus the mean. So for example, over here the mean is 100 divided by the standard deviation, which is 15 in this case. So if I want to convert any I value into its z value, its corresponding z value, I have to use this formula. Using this formula over here, I can change any I value to a z value. So for example, a general question we might be asked is to find the probability of someone's IQ being less than 120. So I'll convert this I value into z value. So I'll convert the I distribution into the z distribution, and the corresponding value will be 120 minus the mean, which is 100, divided by the standard deviation, which is 15. So I get probability of z less than 1.33. So from here I get 1.33, which is 0.9082. So the probability is 0.9082. We could apply the table here quite easily. However, for some other values, I'll get values such as z less than 1.335, for instance. We have the probability of z less than this. We don't have this value over here in the table. We have 1.33 over here and 1.34 over here. I don't have 1.335. It's exactly in the middle. So if I have to find a probability such as z less than 1.335 or less than 1.334 or less than 1.336 or around, I'll have to find the average of the values. So if I have to find the probability of z less than 1.335, this will be equal to the mean of 1.33 and 1.34. The value lies exactly between them. So if I find the average of their probabilities, I'll get an accurate expression for it. So I get 0.9082 plus 0.9099 divided by 2. This only works for cases with 4, 5 or 6. If I had something else, so if I had a z less than 1.331, I'd just use the value for 1.33. If I had 1.339, I'll just use the value of 1.34 directly. We only use the average in cases like this, when we have 1.335 or 0.015 or 0.005. In cases like this, when it ends with a 5, 4 or 6. A 4 SF number or a 3 decimal place number that ends with a 4, 5 or 6. So this is the cases where we use the average. We do not use it anywhere else. Now this is one way to use the table. We can also use it the other way around. So I might be given that probability of the IQ being less than a variable. I can take this to be y, for instance, is 0.731. Now we know the probability. I have to find for which value of IQ I get a probability like this. So as usual, I have to change I into z. I get z less than, y is the I value now, so y minus 100 divided by 15, which is 0.731. Now we know the probability, but we do not know the value of z. So we can use the table. Now instead of seeing left to right, I'll see right to left. So we have a probability of 0.731. I have to find what is closest to it. I had 731. If I look over here, it's gonna be in between over here. In these cases, we do not have to find the average. I'll just take the value which is closest to it. So my probability was 0.731. Its difference from 0.7291 is 0.731 minus 0.7291. This is the difference between the actual probability and the data book value is 0.0019 for the first case, and for the second case it's 0.0011. 0.0011 is smaller than 0.0019, so the gap between the probability and 0.7321 is the lowest. Now using the table backwards, I get the z value of 0.62. So y minus 100 by 15 is the z value. This is 0.62. From here I can find the y value. The y value will be 100 plus 15 times 0.62, This is 109.3. Now for certain values of probability, we can use another table which is in the next page of the data booklet, this table over here. If I look at this table, it calculates 1 minus the probability. So this case over here is when z is greater than a certain value. So normally in the previous table we were given z on the left and the probability on the right. Now in this table it's flipped. We have the probability on the left, and if I know the probability I can find the z value. So if probability is of z greater than 0.5, z greater than anything, consider alpha is 0.5, the value of alpha will be 0. Or if the value of probability is 0.1, the value of alpha will be 1.2816. This table is only used for certain values. We have 1, 2, 3, 4, 5, 6. So 12 values over here in this table. It's only applicable for 0.5, 0.4, 0.3. It's applicable for probability z greater than alpha to be 0.5 or 0.3. But we can do our calculations using z minus alpha. So to reduce the hassle, I'll look at the probability as 1 minus itself. So actual probability over here, if I use less than, this is 0.5, this is 0.6, this is 0.7, this is 0.8, 0.85, 0.9, this is 0.95, 0.975, 0.990, 0.995, 0.9990, and at last we have 0.9995 for probability z less than alpha. The converted probability values are basically 1 minus the value of p on the table. So for example, if I'm given a question where I have to find z less than alpha is 0.95, I'll consider this value over here. So the value of alpha will be 1.6449. We use this table when the value of probability is one of these 12 values. So that was all the basics and the concepts about normal distribution. Now we'll learn about some trick questions that we might be asked. The tricks are normally based on the question. So the question will try to be confusing. So even if you know the concepts, the problem will be deciphering the question. One type of that would be giving you modulus inequalities. So if I am given, we might be given an inequality like this. So x or I, which we were learning, minus 100 is less than 15. For any modulus inequalities, we have to find the inequality by placing a plus in the front ones and a minus in the front ones. By putting the plus over here, I get I minus 100 is less than 15. I get I is less than 115. And if I put a minus in front, I get minus I plus 100 is less than 15. From here I get minus I is less than 15 minus 100, which is 85. minus 85. If I cancel out the minus, the inequality sign will flip, so I get I is greater than 85. So basically this question is asking you the probability of I between 85 and 115. But they asked you in a trickier way, which might confuse you. So even if you know this, you know how to calculate this, the problem will be deciphering the question. Another type would be asking you that probability of something being close to a value. So finding the probability of IQ being close to 100. If we are given a value like this, we have to do the value plus or minus 1 SF more than that or 1 DP more than that. If I was asked to find an IQ near 100.5, I'll do 100.5 plus or minus 0.05, not 0.5 over here. We wouldn't need such precision. Normally we'll be given a whole number, we'll do plus or minus 0.5 and find the probability for it. If I subtract 0.5, we get 99.5. If I add 0.5, I get 100.5. In this case, we are finding the probability of the IQ value falling between 100.5 and 99.5. We have to find this. We know how to find this, but we would be thrown off by this question at first if I didn't know the steps to follow. Another would be linking the standard deviation and the mean. One type of question is being asked to find the probability within one standard deviation of the mean. This is the most common one. So this is another common question, to find the probability of the variable being within one standard deviation of the mean. For such cases, we know the standard deviation. For our example, the standard deviation is 15, the mean is 100. Being within means plus or minus. So the value of I is one standard deviation away from the mean. So one standard deviation more than or less than the mean. The mean is 100 and we have plus or minus 15. So it basically is asking us to find the probability of the I value being between 85 and 115. This is what they are asking basically. The value of I being being between 85 and 115. I can just convert both values into Z. So I first apply the formula for a combined inequality where I is between two values. This is what we get. From here I can convert both of them into Z values. This is 115 minus 100 divided by 15 minus the probability of Z being less than 85 minus 100 divided by 15. I get a Z value of 1. So I get probability Z less than 1 minus probability of Z less than minus 1. I know that the probability of Z being less than minus alpha is 1 minus the probability of X being less than alpha. If I apply this over here, I get probability of Z less than 1 minus 1 minus the probability of Z less than 1. So we get probability of Z less than 1 minus 1 minus times minus. So this will become plus. We get minus 1 multiplied by minus probability of Z less than W less than 1, which will be plus probability of Z less than 1. This is basically 2 times the probability of p z less than 1 minus 1. Now we can use the table. We have to find z's value, the probability's value when z is 1. So when z is 1, the probability is 0.8413. So 2 times 0.8413 minus 1 is our answer. This comes out to be 0.6826. This question or this answer is also the answer for this. This is the same inequality. So the answer would be the same. And that's all for normal distribution.